Hello students, this is Mr. Volts here with a rock introduction for you. You'll find this information on pages 156 and 160, or through 160 rather, in your textbook, which is Module E at this time. So starting off here, it's really important that we understand what is a rock? It's a very important question. We already know what a mineral is, that a mineral is a pure substance, it is a crystalline solid. We know that a mineral is going to be chemically the same throughout, so no matter if you take a sample over on one side or the other, it is going to be chemically the same. Rocks are very different. So like minerals, they are naturally occurring. They are solids, but keep in mind they are mixtures of one or more minerals. And they may also include organic matter, so plant matter, or possibly shells of organisms that were once living at one point in time. Now, here is what your notes will look like when you come back to class and get them. But at the very beginning, it's important that we understand some very basic terms within the different processes that will actually change a rock. And so at the beginning, we have weathering. And weathering is whenever you take water, or wind, or ice, or even a change in the temperature. You know, if you go from super hot to super cold really quickly, those things will break down a rock. Now students, you may be thinking, is this real? Will this really break down a rock? But yes, it is real, it is true. You will really break a rock with water, wind, ice, and changes in temperature. Now, once that rock has been weathered or broken down into little bits and pieces, the next word is erosion. Okay? So first off, we have weathering here. Then we have erosion. Okay? So erosion is when sediment is moving from one place to another. Okay? So for your picture, I'm going to allow you to draw whatever you would like over here in this location for all three of these. But if you take a rock and it goes from one place to the next, basically anytime a rock is moving, or any sediment, the sediment includes sand, dirt, gravel, even boulders can be broken down into sediment as well. Anytime they're moving from one place to another, that is considered erosion. And then when they stop moving, students, that is called deposition. When a sediment comes to rest, when it stops, okay, that is deposition. So I'll have you right now just pause for a moment, pause this video, and I want you to draw pictures for each of these vocabulary terms. All right, moving on to our next category where we actually break down into three different categories of rocks. So at the very top here, we have igneous rocks. And it's important, students, to understand before we even get into igneous rocks, the difference between magma and lava. So I'm going to draw for you just a very simplified rendition of a volcano here. And if at any point in time you have molten rock that is beneath the surface, okay, so this is underground, you can imagine right now, okay? So if you have molten rock that is beneath the surface, that is called magma, okay? So this is considered to be magma. But as soon as this erupts from this volcano, it then becomes lava, okay? Now, you may be like, why would they do two different terms? One of the things that helps us students is that magma, when it cools, it's going to cool very slowly, whereas lava, because it's out in the open air, will cool very quickly. Now think, how do you think that's going to change? How do you think these things, or this is going to change how these will form different rocks? So if it's cooling slowly, you're going to have large crystals. If it's cooling quickly, you're going to have small crystals. So that's a helpful thing between magma underneath and lava above. Igneous rocks are formed when magma cools, okay, and hardens both under and on top of the surface of the earth. Okay, and in a moment, at the end, I'll have you pause and draw your image over here in your notes. In sedimentary rocks, they form when you have minerals that are forming from a solution. Like if you have a glass of water and the water evaporates and you're left with that crusty grossness around the top of your glass, that is considered a sedimentary rock, or sedimentary rock, technically speaking. Okay, this also is like rock salt. Okay, so oftentimes that comes when seawater has evaporated and you're left with the salt, the stuff that was dissolved in that water beforehand. Or you can get it, so you can get it from a solution, or you can get it from sediment that is pressed and cemented together into a ball. So for instance, if you take all these grains and they were cemented together, okay, you can then end up with a rock that is a sedimentary rock. I want you to draw your picture here as well in your notes. And the third kind of rock that we're going to talk about is if you take either an igneous rock or a sedimentary rock. You can see how I'm drawing this arrow down here. This is going to come into play later. And you squeeze it under intense heat and intense pressure underneath the ground. And you end up with a new kind of rock. So temperature, pressure, and sometimes even chemical changes will change an existing rock into something different. And I want you to add your image here as well. Now students, coming back over here to this section, okay, you notice how igneous rocks and sedimentary rocks can turn into metamorphic rocks. Well, let's think about this. Do you think it would be possible to take a metamorphic rock, bring it to the surface, and break it down through weathering and erosion? Yeah, it's very possible that you can do this. So when a metamorphic rock gets broken down into many little bits and pieces, and those are cemented together, you have, yep, you guessed it, you're going to have a sedimentary rock. Now, let's say that, coming back to this metamorphic rock here, if it comes in contact with molten rock again, and then that gets melted and then hardens, you will then end up with an igneous rock. Or let's say you have an igneous rock here, and it's up on the surface, and there's a lot of wind, and it breaks down over time, and then those small sand grains or pieces of sediment get cemented together into a new rock. You will then have a sedimentary rock. So students, there's a lot going on here. I recognize this, and it looks kind of messy. But what I want you to begin to see is that it's actually a cycle. And that cycle can make sense for us here. So make sure you have your images in there. Here are a couple images of different rocks. This is a piece of sandstone. Okay, you can see the layers of the how the sand came down and was compressed together. We also have another image of sandstone. This is a different example. You can't necessarily see the lines, but throughout this whole thing, there are grains of sand, rather, that have been cemented together over time. So those are both examples of sedimentary rocks. This next one is an example of an igneous rock. This is granite that I found as I was walking out in California, up in the Inland Empire, out in the desert. And I thought it was a great example because you can see how all of these little different bits and pieces are actually different kinds of minerals. Okay? And the crystals are a lot bigger than we had over here. Okay? And so they had time to cool. Now this was a sedimentary rock, so don't allow that to confuse you. But this igneous rock is a wonderful example of magma cooling slowly over time, because these crystals are fairly large. Next, we have a metamorphic rock here. This is an example of gneiss, not spelled nice, but spelled G-N-E-I-S-S. Okay? So not spelled this way. Okay? Now, students, you can kind of see there are individual bands here, but it looks like they're all squished together. Some are a little bit thicker, whereas some are thinner, and they're not all exactly going in the same way. This is a metamorphic rock. This is a metamorphic rock. Okay, and at the very end here, we have the rock cycle. And it's basically, students, just a series of processes where rocks change from one type to another. So if we have our sedimentary rock, we have our igneous rock, and we have our metamorphic rock. When a metamorphic rock goes to an igneous is sedimentary to metamorphic. And each of these arrows can go in the opposite direction as well. And they can go across the way as well, okay? So they make a complete cycle here. and make a complete cycle here. And that's really important to remember. We'll be talking about that a little bit more when you come to class. Make sure that you remember to grab these notes so that you can get them filled out. Remember, if you ever have any questions, my door is always open. Thanks, guys. Talk to you later.